Hey guys, today we're going to be taking a look at this problem. If the region in the first quadrant bounded by the curve y equals e to the power of x and x equals 1 is rotated about the x-axis, what is the volume of the resulting solid? And feel free to pause the video and give this problem a go before I go over the solution. Alright, so hopefully you gave this problem a go, but when we are dealing with volume and I see that there's a curve y equals e to the power of x, usually we're probably going to be dealing with integration. So let's first graph what this y equals e to the power of x will look like so that we can get a better grasp of what integration expression we kind of have to solve for. So we know that it is located in the first quadrant, so I'm just going to draw the first quadrant right here. This is the y-axis, this is the y-axis, this is the x-axis, we have 0 here. And it says y equals e to the power of x. We know roughly that graph is going to look something like this. Y equals e to the power of x. This is 1, and there we go. What are our upper bound and lower bound, basically? Well, we know our upper bound is x equals 1. It explicitly says in the problem. So x equals 1 is going to be over here, x equals 1. What is our lower bound? Well, it's not specifically stated here. That's why we need to take a deeper look into the problem. But we see in the first part of the problem, it says if the region in the first quadrant. First quadrant is basically 0 all the way to infinity towards the right side. So that means our lower bound is going to be x equals 0. X equals 0. So we're basically finding the volume of the curve y equals e to the power of x rotated about the x-axis between x equals 0 and x equals 1. But how will this volume / 3D figure actually look? Well, it's going to look a little bit something like this. And that is my best attempt of how it would look. But for right now, while it would look like this, they're just asking us to find the volume between 0 and 1. So we just need to find the volume of the figure, or volume of the 3D shape, in the red part over here. That's all we need to find. So since we already know the lower bound and the upper bound, we can set up a small integration. So 0 to 1. Something is going to go over here, and we know we are integrating with respect to x. So we just need to figure out what exactly is this something over here. And we know that we are dealing with volume, and we know that when we integrate a function, we get the area beneath that function, and when we integrate area, we get the volume of that 3D figure. So we essentially need to find the area of this red part. Well, how do we do that? Well, this red part, we can kind of simplify it, that it's nothing but a bunch of circles just lined up next to each other, infinitely many circles going from x equals 0 to x equals 1. Over here, I drew like, 3-4 circles, but in essence, it's actually going to be infinitely many circles. So we can get every single little gap filled with those circles. So we just need to find the area of one circle, and then we can integrate it 0 to 1. And we know that in order to find the area, we need to find the radius of the circle. So let's say this is the radius of the circle we're trying to find. So what is the radius? Well, the radius is basically this part over here. So if we can assume this is a circle, the radius is this part. And this is nothing but y equals e to the power of x. So we could say that the radius is e to the power of x. And the length of the radius will change with respect to x. The greater x is, the longer the radius would be. And the shorter or smaller x is, the shorter that radius would be. So now we got our radius is equal to e to the power of x. Now we can find our area. What is the area of a circle? The area of a circle is pi r squared. The radius is e to the power of x squared. A equals pi times e to the power of 2x. And therefore, area is just pi e to the power of 2x. So that will go right in there. So integration 0 to 1, pi e to the power of 2x dx. Now we just need to solve for this. Well, we know pi is just a constant, so we can take that pi out of that integration. So we have 0 to 1. Now we have e to the power of 2x dx. Integration of 2x is going to be e to the power of 2x divided by 2, 0 to 1. Now we just replace those upper limit and the lower limit, so we get e squared over 2 minus 1 over 2, because e to the power of 2 times 0 is e to the power of 0. E to the power of 0 is just 1. And we can also see that from this point over here from the graph. And simplifying this, we get pi e squared minus 1, 2. And that is the area. Let me just circle it. That is not the area. That is the volume of the region bounded by the curve e to the power of x and x equals 1 when it is rotated about the x-axis.